help kick off the session part of Alliance Day, as well as for this group NIWeek. And hopefully it's a fantastic week for everyone. Very insightful information. We'll hope to kick that off on a good note here. Introducing one of our newest products, which is a new CompactRIO controller called CompactRIO with NI DAQmx. I'm Eric Myers. I'm our product manager for our CompactRIO controllers, also our single RIO controllers, but for the purpose of this presentation, mainly our CompactRIO controllers. I'm really excited to talk about these new variants and options that we have and some of the key new features that we've integrated into it, and kind of talk about the background of the product a little bit. And so I'll start with a quick quiz for everyone, or really just a question. As we look at CompactRIO and Compact DAQ controllers, so I'll start with this. Who here has used CompactRIO before? Right. I had a feeling pretty much everyone would say yes to that, especially with this audience. What about Compact DAQ controllers before? What about specifically the controller? So not the chassis tied to USB, but the standalone controller. So we saw a handful of those as well. Awesome. So just to make sure we're all on the same page, CompactRIO and Compact DAQ controllers in many ways are very similar. Both feature the same rugged specifications. Both have up to 8 slots for C-Series I/O, so a wide breadth of I/O that you can integrate into the product. Both have the same real-time operating systems. Compact DAQ controllers do also have the Windows options. But what's really kind of unique about one versus the other is when you get down to it is CompactRIO has that FPGA, has that powerful processing unit in there that allows you to do some very advanced and very flexible things in your applications, such as high-speed control or maybe custom timing triggering for data acquisition, for doing some custom data acquisition. Whereas the Compact DAQ controllers on the right side are going to feature that DAQ ASIC that make it really optimized for getting data acquisition, so doing things like waveform measurement streaming, or just generally speaking, getting data back without having to go too in the weeds of programming, which is very good for kind of quick getting started material. And so when we released CompactRIO back in 2004, so about 14 years ago, released CompactRIO, is really meant to fill this void. We saw a lot of data acquisition customers wanting to do more control in their applications. And so what we realized is we need some product that's kind of better suited for control than what we have today in this type of form factor, in this kind of smaller form factor that's not quite the size of a PXI device. And so what we ended up doing was creating CompactRIO and put that FPGA in there, which really allows it to be powerful and allows people to do some really advanced and very interesting things. Whereas in 2011 we released our Compact DAQ controllers, which were kind of more towards the Compact DAQ chassis that we introduced, which is kind of that DAQmx kind of ease of use type of experience, but now with the standalone headless operation capabilities so that you can run it as a standalone operation. So you don't necessarily have to tie it to a PC, but instead you can run it in an environment and it will stand alone by itself and operate. And so when we look at that from a kind of an application perspective and kind of compare these two, again, a lot of these do have quite a few of the same features. But we see as one product that was initially kind of developed more so for control, and one product that was developed a little bit more for kind of the data acquisition side. But what we also see now, especially over the years as they continue to evolve, is that these kind of merge together a little bit. So we see a lot of data acquisition customers that are now starting to add control to their application. So as they're trying to understand or maybe characterize a device, or as they're trying to do testing on a device that they need to take measurements on, what they've realized is a lot of these they need to add some kind of actuation to that. So they need to put things into a certain state that requires an output, or in some cases they need to go to the level of doing closed loop control to be able to actuate or control this device that they're trying to measure, so they can do something and then get a response based on that. And so Compact DAQ controllers today can manage that to a certain point, usually up to about the tens of hertz. So it does actually bleed a little bit into the control space. And then CompactRIO, with the flexibility, there's a lot you can do with it. You can do a lot of measurement stuff and custom measurement stuff, but it's not always the easiest to use as you're trying to do that as well. But we see a lot of customers that have typically been in the control space. Let's say, for example, they have a piece of heavy equipment that they're trying to drive using a CompactRIO controller, or a machine that they're trying to they're using as a control to operate things like motion, acquire vision input, and do several various forms of output based on all that information. Now we see things like people trying to add things like health monitoring or condition monitoring to those control systems, where now they're starting to add more waveform data and more acquisition data into the systems. And so these are slowly, both from a user and what people are trying to do with these products, and even from a product perspective, kind of merging together over the years. And what we want to do now is truly kind of merge those together into one single product called CompactRIO with NI DAQmx. And so now you have one product that's truly well suited for both control and measurement all in one application. And you get kind of the best of both worlds here. You get that really nice, really powerful FPGA on board. You also get the kind of ease of use and the ability to do the data acquisition using the right API with DAQmx all in this one product, which especially from this group here, I'll maybe ask another question. Who here has had to decide between CompactRIO and Compact DAQ controllers for an application before? Has it usually been pretty easy? Is that sometimes challenging? I hear a lot of laughs, so I'm going to assume more on the challenging side. And it is, because there's a lot of trade-offs of, do I want to go more towards flexibility on one side, even though I may not need all those features today? Do I want to stick on one side? Am I going to need one more in the future? It's kind of tough to decide, and the reality is we don't want you to be stuck there. We don't want you to have to decide which product to use at that level. So now we're all bringing all this into one product. You can now get CompactRIO with DAQmx and decide which programming mode is best for you, given the application, and you can mix and match them as well to do both together better in one product. So to show it off, again, this is CompactRIO with NI DAQmx. I have a nice controller up here. It's kind of dark in here. Hopefully everyone can see it, but it's too hard not to take the opportunity to do a nice Lion King move and kind of raise it above my head, so I do want to show it to everyone. And especially since everyone here, according to the beginning, has seen CompactRIO before, and certainly I'm sure everyone here knows what it is. It looks very similar. It looks exactly like a CompactRIO controller that we have today. And that's really by design. Is it's not overall necessarily a brand new product, and it's not the outside that's new. It's still the same kind of outside, the same ruggedness, the same C-series capabilities. It's now more about what inside that matters, so bringing in this API features and some others. And so 3 specific callouts that I want to mention, and we'll go through all these throughout the presentation. One is now you have the ability to choose on a slot-by-slot basis which programming mode you would like to choose. So for each individual slot, you can choose between DAQmx, you can choose between LabVIEW FPGA, or we'll get this I'll briefly mention now, you can choose scan engine, so the RSI as well as an option. Next one is integrating TSN into the product, which we did introduce a couple years ago on an early access release product on CompactRIO, and especially on the Compact DAQ side with some of our chassis or our field DAQ nodes that we've announced recently. We're continuing that investment within bringing in this industry standard TSN into our products. And then last but not least, it's important to note this is a replacement product for our existing CompactRIO and Compact DAQ controllers. So if nothing else, this is the latest and greatest CompactRIO and Compact DAQ controller that has several kind of interesting new features as well that we'll talk about. So we'll go through those. Let me get through this section real quick, then we'll pause for a second. So each of these 3 bullets we will expand on as well. So we'll probably hold questions till the end if that's all right. And so first is we have actually already released and done a live announcement, but we're doing more of an announcement here at NIWeek of the very first variants of these CompactRIO with NI DAQmx controllers. So specifically, this is the C0904X product line, and this is going to be the highest performance products that we offer with CompactRIO, within CompactRIO with DAQmx family. And so this is our kind of latest and greatest maximum performance that you can get out of the product. And again, I mentioned for the most part, it looks and feels like a CompactRIO controller. It shouldn't really look that different to anyone from the outside. We're keeping a lot of the same features, same capabilities. A couple key ones I do want to talk about though, one of which is feedback that we've been hearing from groups like this for a long time, for at least a couple years now, which is trying to integrate USB 3 into a controller. So a lot of laptops now have been integrating USB 3 for a little while, and people have been interested in seeing that in controller. So despite the thermal challenges that come with USB 3 and how much more power that is from USB 2.0, our engineers are luckily very skilled, and we're able to integrate 2 ports for USB 3.0 connectivity within these new controllers. And that's interesting for a couple of reasons as well. And we'll talk a little bit about the USB ports a little bit later though. And another one is the PFI trigger that you see in this upper portion here, which is something that if you've used a Compact DAQ controller chassis before in the past, you're probably used to. Largely used for signal-based synchronization across distributed devices. And it's something that as we integrate this new synchronization technology of TSN, honestly was a big question of whether or not we do include a PFI trigger line for synchronizing some distributed measurements, since we have this Ethernet capability. But the reality is we think there's enough people out there, especially from our existing audience, who will need to continue to use signal-based synchronization for some of their different acquisitions that they're doing. So we did make sure to keep that part of the design around as well, which is now the first time we've integrated something like that into a CompactRIO controller. Coming out later this summer is going to be another onset of CompactRIO with NI DAQmx controllers, which is the CRO905X product line. And so these are going to be more of our entry-level variants. So if you're familiar with our CompactRIO offering today, these are the replacement for the 906X products that you'll see coming. And so here you can see a pretty familiar form factor as well. We've already talked about some of the key things like USB 3 we are integrating into here as well, keeping the PF5 trigger line, having the TSN-enabled Ethernet ports. A couple things I want to call out here. One, this is, I think, if you're used to using a compact DAC controller or an application that might use a compact DAC controller. In the past, we've only offered that DAQmx type experience on our highest end controller options, and they've been kind of co-owned between our highest performance CompactRIO controllers and then the high performance compact DAC controllers. So this is actually now a new variant of compact DAC controller that's never been around before at a new price point. And so if you've tried to do something like an in-vehicle data logging application, or try to win an application like that that needs a standalone operation but also relatively lower cost than what we offer today, this is now a new variant that may potentially open up some applications in that space for you, which is very exciting for us. And then in a similar vein on the data logging side, we did integrate microSD into this new product as well. The reason being, as we integrate DAQmx, you can expect a lot more measurement applications within the product. And so as you have measurement applications, you also need to be able to store a lot of data alongside that. And so a lot of people like the SD within the existing CompactRIO controllers, and so we've now added a micro SD version of that onto our new CompactRIO controllers for the 905X. And so alongside that, even beyond just the measurement applications, we do have a lot of customers that are in very rugged environments that like to store data as well, whether it's maybe fault data or if they're doing things like health monitoring or condition monitoring, then they want to store some of that data in case there is a fault to make sure they understand what's going on in the machine. So now they have expanded storage that they can log data to. And so within the same vein of that, I actually want to call out, this is maybe a little bit of a side, but an additional product that we're coming out with here shortly after NIWeek, a little bit later this summer, which is a new type of accessory alongside CompactRIO, which is called an expansion module for CompactRIO. So I have a variant up here in front, and you can see if I put these two together here, how neatly one of them can fit alongside the other. It's a very similar form factor to CompactRIO, features the same ruggedness, same shock and vibration temperature ratings as our CompactRIO controllers. And what this is really meant to do is expand some of the processor I/O to be able to add more capabilities alongside the controller. Specifically, the variant that we're releasing later this summer is going to be an SSD variant. So this is now a solid-state drive that you can put directly in rugged environments next to a CompactRIO controller, and also mounts very seamlessly. So we have a similar DIN rail option like we do with CompactRIO, and also a panel mount option alongside CompactRIO, so you can mount this directly next to the device. For the SSD, one, this will be one of the highest read-write performances that you can get out of a controller. And two is we're going to have several options. So there will be a 64 gigabyte SLC option, which is really good for high endurance within rugged environments, especially a very high temperature range is very good. A 480 gigabyte MLC option. So this type of technology is good for generally just high capacity if you're not going to be within a rugged, so maybe like a lab type environment, MLC works well. And then also just an inside carrier. So if you want to include your own SSD and say you need a specific drive or type of technology or combination of the two, you can include your own as well. And we provide just a carrier on the outside. So you have this nice form factor that you can integrate alongside, but include your own module alongside of it. So that's actually a great question. You can use this with more than just CompactRIO. So in terms of integration, it obviously works, integrates very cleanly alongside CompactRIO, but you can use this among a lot of other products as well. So for example, this could easily tie alongside a industrial controller or even like a PXI chassis as well. So any device that has a USB that you want to store data from, it's just a USB connection. The CDAC controllers you could, the CDAC chassis, you need some type of OS in the way to do the file management and data storage. But the existing compact DAC controllers, you could integrate this alongside as well. because it is just a USB port. We are using USB Type-C on here, but you can use a USB-C to A converter to connect to existing like USB 2.0 ports. You just won't get the read-write speeds that you do out of the USB 3. And so for most of the rest of the presentation, I'm going to go through those three kind of highlights that we mentioned. So the programming mode capability options, the TSN support, and then some of the upgrade features as part of the replacement products. But before I get into those three things, I did want to call out this specifically, which I imagine is probably a question for a lot of people in this room. So everyone here kind of mentioned they've used CompactRIO or CompactDAQ in the past. So you have existing applications, existing code base, existing knowledge that you've built up around these products. And one of the first questions we often get from people who have done that is, I have all this stuff today, what does that mean for me moving forward? Am I going to have to completely change my mentality as I do this? And the answer to that really is no, you don't really have to. We've worked really hard to make sure that, that you can very seamlessly move applications forward and use that same existing knowledge that you have today. We don't want to take that away from what you've been developing so far. And so as we've integrated these two together, we've worked very hard to make sure that we can provide that same experience. And so if we look at it from a few different levels, first of which is the programming level. So again, I called out, it is the same exact experience. It's still, if you're a CompactRIO user, you're still using LabVIEW Real-Time, LabVIEW FPGA. If you're a DAQmx user, you're still using DAQmx to be able to get your data acquisition across. And then from a performance perspective, you're not going to see a performance hit by integrating these two technologies together. And specifically in order to make this happen, we actually did this change at a hardware level. So we didn't just implement some of the DAQmx functionality within the FPGA. It's a completely separate ASIC that allows you to go in between the two of them. And so depending on which mode you choose, you will actually have different paths and different routes for DAQmx data versus LabVIEW FPGA data or RSI data that may be coming across. So one of the common questions is, if I have a control application today that uses the FPGA and I want to add in DAQmx, how much FPGA space am I consuming? And the answer is 0, because it is truly a completely different path. And if anyone is interested, there is a session on Thursday of this week where one of our chief engineers will provide a little bit more background around the kind of the architecture of this and provide kind of what those different paths are and what that actually looks like. I'll have a slide here at the end that talks about the time for that one. And then last but not least, the question that people also like to give is, what about price? And this is something that we're truly adding in. So we are keeping the same price points today we have with our CompactRIO and CompactDAQ controllers, but now integrating the new technology in for all its replacements. And then, of course, I mentioned this as well, for the 905X products, that's actually a new price point our CompactDAQ controllers have never had before. So the reality is we're actually kind of improving price even for some of the applications that are out there. So with that behind us, just want to give a little confidence at first of, you can kind of give a nice sigh if you want to, relax, whatever it may be, but you can continue to use your applications, your experience, and migrate everything forward quickly, just like you would expect in the past from a new controller option. And so with that, let's go ahead and dive into the three different main topics, which are, again, the programming modes, TSN support, and this kind of upgrade features as part of the replacement product. So going into the multiple programming modes, there are three programming modes that are supported on a slot-by-slot basis for these new controllers. One is called real-time, the next one is real-time scan, and the last one is LabVIEW FPGA. So real-time is going to cover drivers like DAQmx or XNet, so obviously DAQmx for its waveform streaming capability, and then some of the other processor-based drivers such as XNet will all be supported within this programming mode. Next is real-time scan. So this is, if in the past you've used, I'll call out several different names here, but something like the RioScan interface or RSI or Scan Engine, that all kind of refer to a similar thing where you have a node that you can just drop down into LabVIEW real-time. We do have support for this as well. I do want to specifically call out on the scan, the real-time scan option though, that we specifically wanted to put this in here and put the effort to put this into the product, because we know a lot of people in this room and a lot of existing applications do use RSI in many of their existing setups today. And so from a migration standpoint, we wanted to make sure to include this. But for new applications moving forward, we would recommend using DAQmx instead. And we know there's different use cases for RSI, and we'll get into a little bit about kind of DAQmx on CompactRIO and how that will help address some of the use cases for Scan Engine for RSI. And then last but not least is LabVIEW FPGA. which of course then gets you into that kind of high power FPGA where you can do a lot of high-speed control, advanced control, or customization of acquisitions. We'll go ahead and take a...
So with the support for RSI real-time scan I/O variables being, we're supporting it because it's there, but we're sort of not recommending it moving forward. What about the expansion chassis, where the RSI is the primary methodology? Is that something that is expected to change, or just RSI will be it for that, but you're recommending different for the new controllers?
Yeah, so the question is around, with not recommending RSI, does that mean some of the other things that take advantage of it, such as expansion chassis, or where you can throw things like motion control with soft motion into that? And the answer to that is, when we talk about RSI in this case and not recommending it, it is specifically for the modules that are integrated into the controller. For existing things that use the scan engine for synchronizing things for motion control, or such as like the EtherCAT chassis, some of the behind-the-scenes stuff, that still exists in the programming experience will still be the same for those. And on the next slide, we'll actually even talk about a new expansion option for this that's, I think, really interesting as well for expanding beyond 8 slots. And so, to dig into specifically 2 of these, this will likely be the last time you hear me mention the RSI option for the reasons stated up there. But specifically, we'll dig into DAQmx and FPGA a little bit here. So DAQmx, for those who are used to CompactRIO in the past, this is a new option. I'm sure most people in here are familiar with DAQmx. It's a nice kind of simplified API to be able to get waveform and just general data acquisition data across. As you're trying to expand and get measurement data, this is the recommended path to be able to do that. And you can do it very quickly. And a couple of other things I'll call out for CompactRIO previous users. One is with support for DAQmx, we now get the ability in Max, as you're configuring a system, to see your modules in Max and use things like test panels, so you can actually do some quick debugging or understanding and checking of the system as you're building it up, as well as now calibration is technically an option within these controllers as well. And then one thing I want to call out at the bottom here for both CompactRIO previous customers and the Compact DAQ, if you use that in the past, is it's not just the same DAQmx we had on our previous Compact DAQ controllers. We've actually improved it in many ways. One is we made the hardware change. We improved the ability to do multi-rate applications. So previously you've been limited to about 3 different timing engines, and so you could only do a certain number of multi-rate tasks within an application. Now we have the equivalent of a timing engine per slot, so you can do a multi-rate application for each individual slot if you would like to, and really scale and expand your system and not have to maybe make trade-offs into what modules and what measurements go into what task. The other is now, obviously, CompactRIO and the control capabilities is very well known for its deterministic operation, and it's an important part of that control aspect. So combining that determinism with DAQmx, we now have support for a feature that's primarily only been on PXI in the past, which is hardware times single point. So hardware times single point now allows you to do single point control deterministically using DAQmx on the processor, so within LabVIEW real time. So with support for this, you now have, from a DAQmx perspective, the ability to do control loop rates up to about 5 kilohertz deterministically. Obviously, there's a lot of factors that go into that, such as what's the controller you're doing, how intense it is, what processor you're using, so which variant. But so far, we've seen up to about 5 kilohertz being possible there for high-speed control on the processor side. And then last but not least is, of course, the synchronization capability as well. So bringing in TSN, but we'll talk about TSN a little bit more in depth in the next section. And so switching gears a little bit and talking about the FPGA. So FPGA, obviously very powerful. You can do a lot of things such as high-speed advanced control, which I mentioned many times here, as well as a lot of custom timing, customization. And this is something that people in this room have been using successfully for many years now. And you have that capability. If you have customers that have been using only DAQmx in the past but can benefit from an FPGA, now they can do both in the same product, which allows them to scale a little bit better and have an easier transition into learning something like LabVIEW FPGA, where they may not have in the past. Which is actually, I want to take a step back and highlight on DAQmx is, I'm sure everyone in here understands how to use DAQmx, how to use LabVIEW FPGA, and is very proficient in all of those. But it's probably worth noting, especially on the CompactRIO side, I'm sure you have several customers you've worked with who are not proficient in LabVIEW, LabVIEW Real-Time, LabVIEW FPGA, and especially as you try to get into the LabVIEW FPGA level, it's a bit of an on-ramp for your customers to learn LabVIEW FPGA. And so having support for DAQmx on this product is actually also a nice stepping stone for your customers, as you can start them out with DAQmx on the processor, and then just kind of work them into LabVIEW FPGA as they kind of start to learn the product over time. So I just like to call that out of, we're not trying to force anyone in this room into using LabVIEW FPGA or NI DAQmx or vice versa. Use whatever you think is best or whatever knowledge you have today that you think is good, but now you have an easier on-ramp and your customers have an easier on-ramp into learning one or the other since they're on the same product. Then stepping back into the LabVIEW FPGA, one thing that's worth noting, especially for a compact DAQ audience, is now there's expanded measurement options for that group. So we have several modules, both NI modules as well as third-party modules that are supported only within LabVIEW FPGA. And so now the compact DAQ controller audience has access to those modules without having to sacrifice that DAQmx experience. If you wanted to use something like A-Ring 429 or Serial or Profibus or Ethernet, or not Ethernet, Profinet or CAN before, you would have to go to using the FPGA for many of those types of modules, which then forced you into CompactRIO, which then meant you would have to use LabVIEW FPGA or RSI to be able to collect your data and get information. Now you can have the slot dedicated to LabVIEW FPGA for that specific module and use everything else in DAQmx, so you don't sacrifice your experience to be able to add some of that capability in, which is really nice. And then, of course, with the high-speed digital capabilities of the FPGA, you can also do some custom interfaces also. And so switching from more of a technology view of it, so looking at DAQmx and LabVIEW FPGA to kind of the application level, if we look at, let's say, a measurement application, if I'm going to use DAQmx, it's pretty straightforward. I'm going to use the API. I'm going to do the open, read, write, close method within NI DAQmx to be able to get data into the processor, maybe do some post-processing there, and then send that data out to something, whether it's a laptop, server, cloud, whatever it may be. With the FPGA, with the FPGA route, if I want to do a similar thing, I'm going to have to create a couple applications here. Of course, I'm going to have to create my FPGA application and my RT application. So generally speaking, if you're just doing measurements, kind of your standard measurements, we do recommend DAQmx because it's going to be a little bit simpler. If you're trying to do some more custom things that the FPGA opens up, such as if you maybe now want to add some processing into that FPGA. For example, if I want to do frequency-based measurements, I can take that raw measurement data, do some frequency calculations within the FPGA, and then send that onto the processor for something that the processor may or may not be able to keep up with. So now I make sure that I have that inline processing to be able to get a specific type of measurement or specific types of results from my measurements that I want. Or if I want to do something more custom, such as a custom digital protocol or some custom triggering based on an event that the FPGA is better suited for. But generally speaking, most people will kind of be up in that top portion with DAQmx. And so it's pretty obvious as we look at the code, but I'm not going to spend too long on this because I think most people here know this of generally how much more clean and simpler it looks with DAQmx compared to FPGA, using the existing sample project here to be able to do the same type of measurement. Switching over to a control perspective, as I mentioned, we do have hardware time single point support on this product now. So if you are wanting to do control on the processor, so if you're not wanting to, if you're doing control up to 5 kilohertz, you have an option. You could either use DAQmx on the processor. The nice part there being it's a little bit more of a simplified programming experience, as well as I'm sure this group knows very well, you don't have to compile an FPGA to a bit file at that point and deploy it. So you have a little bit more ability to iterate quickly based on not needing to compile. However, if you're going to benefit from having the FPGA for the control, so for example, if you need the hardware level of reliability for it, so if you don't want to risk an operating system potentially being there, or if you want to make sure you have kind of the lowest jitter possible for it, for the control loops, the FPGA at the hardware level is still good for that, and certainly you can use it for control loop rates under 5 kilohertz, but the DAQmx experience provides a little bit simpler of an experience there, as well, of course, not having to take the time to compile the code. And then if you're going beyond 5 kilohertz, of course, you have the FPGA to really expand into even tens of megahertz if you want to. You have a very powerful processing element there to do some high-speed and advanced control capabilities. And so kind of looking at the code here and diving into what a hardware time single point example looks like on CompactRIO using DAQmx. You can see an example here. I think this loop here is going to look very familiar to all customers, where you have a read, you have some processing, you have a write, kind of simple, let's call it a PID type application, or your generic control application. And everything else from a compact DAQ perspective, it looks just like DAQmx. It looks like anything you would do for a waveform streaming type application. The difference now is it is deterministic, and you can meet kind of high-speed control loop rates up to about 5 kilohertz in there. And then for those on CompactRIO using the scan engine today, again, the loop will look very familiar. You will now have some kind of configuration and stuff you have to manage outside of the control loop compared to just dropping a node in. But the nice benefit is you can now potentially achieve rates up to 5 times that of what you were doing previously with RSI. And so now you have more capabilities to expand beyond the loop rates, which is something we've heard from this group before is, I want to use RSI, but I need to go somewhere between 1 and 2 kilohertz. And this does that pretty well, where RSI may have struggled a little bit to potentially meet that in the past. Switching over to the FPGA, this group does it pretty well. You can do things from very simple, such as PID here. That looks pretty clean and straightforward, all the way to very advanced options. In this case, I took one of our soft motions examples to do field-oriented control for a brushless servo drive. And so you can see pretty advanced control, and then as you dig into the sub-VIs of that, you get even more advanced control down below, and advanced algorithms that need to run at high speed in the tens of kilohertz range. And so you need something like an FPGA to be able to manage that. And this allows you to do that and kind of customize your control loop specific to your need. And so let's actually go ahead and look. I'm sure many people here are curious. And I'm going to try not to double mic here, so I'm going to take this one off real quick. And make sure people can hear me still real quick. All right, we see some nods. So I'm going to do a demo, and the demo is not going to be anything super advanced. What I want to do is just show you kind of the new experience, what it looks like real quick, and as you're getting started, what changes a little bit. So first of all, I'm going to start out in Max, and I already have a CompactRIO controller here. So it's one of the new Serial 904X controllers. I have several modules in here, and I am connected over the USB Type-C port directly to my PC with a USB-C to A cable, which, don't worry, is included in the shipping kits. So you don't have to go out and buy your own. It does come with the kit, and you may or may not be interested to hear this as well, but we also now include a screwdriver in the shipping kits also. So you now get a fancy and nice screwdriver with each purchase. So if that's not reason enough to purchase, I don't know what it is. So looking at the experience here, you can see I have my CompactRIO controller. I'm identifying it the same way I would any other CompactRIO controller. It shows up in my remote systems. I would install software the exact same way as well. But now, under the devices and interfaces, I have a chassis that has all of my modules underneath. And you can see here different icons, which are going to directly relate to what programming mode my module is in. So I've already gone through and done some amount of configuration. By default, we're generally going to start these in NI DAQmx, because that's where we would recommend people get started, because you get your quick measurements and quick capabilities versus some of the other options. However, if I want to, I can go in and I can change the mode. So in each of these modules, I have a programming mode option now that I configure. So if I want to, I can choose LabVIEW FPGA as my programming mode. I can save it, and then I see the icon switch, and now that's set to be programmed in LabVIEW FPGA, and I can use that on an FPGA diagram. I'll go ahead and switch back to my real-time DAQmx, though, and save that, because I do want to specifically show off for this first module, this universal module, I do have a thermocouple hooked up to it. And so I want to show off the fact now I can also click test panels for these devices. I have the right channel already. I am going to go ahead and bring down my voltage levels, since it's a thermocouple and it's usually pretty small voltage levels, and start running here. And now, quickly after startup, I can see that I'm getting data, and I can put my thumb and finger on it and rise that data. I can take my hand off and see it drop back down, and really get some quick validation that my modules are hooked up correctly, they're working, and I have more confidence as I'm getting started with my application. I don't have to do some quick FPGA test to see, or RSI test to see if my modules are working. I know that now before I even enter the LabVIEW experience at all. And so, for the sake of later on, I did go ahead and place several modules in different modes. I can see a few of these are in real-time mode. A couple of these are in LabVIEW FPGA mode. I did go ahead and put a couple of these in real-time scan as well, so that you can see how you can truly interact and make all of these on a slot-by-slot basis, different programming modes. As I switch over to LabVIEW FPGA, or sorry, a LabVIEW project, you can see I have a standard project here, and I'm going to add my CompactRIO controller just like I would any other targeted or any other CompactRIO controller in the past. So since it's already hooked up, I'll go ahead and just identify the one that's already connected to the system. And I can see I have my serial 9045 here, so I'll go ahead and say OK. And it will integrate it into the project for me. I'll go ahead and minimize these to clean it up a little bit. And now you can see I have 3 different modes that are available here, all of which are the top 3 here. So under my chassis, I still have my RT controller, just like I always would in the past. I still have my chassis, just like I always would in the past. But now I have 3 individual sections. I have real-time scan resources. As you can see here, these are my modules set up for RSI that I set up towards the end of the controller. I have my real-time resources. So these are things that are going to be set in the processor. So a lot of DAQmx base modules would be in here. As well as, at the end of this, we do call out the specific driver that we're using. So for example, I have a 9860 that's in my controller, and so at the end of it, it actually calls out the fact it's using XNet instead of one of the other drivers. So it does tell you what driver it's based off of currently. And then, of course, I have my FPGA target down here, where I have my modules that show up. So I have my modules that were in LabVIEW FPGA mode, and then I have the I/O available as well. And if I want to, let's say, for example, I messed up and said, oh, actually, this 9260 that's in, or actually, let's say here, my 9401, I actually want to do some custom interfacing and FPGA with this and didn't mean to put it in real-time scan. If I want to, I can just drag and drop from where it was in real-time scan resource to the FPGA target, and now it's going to show up in the FPGA target, and I can use it in LabVIEW FPGA, and I can move them around based on what experience I'd like to use them in and have it available. And so now, once I'm at this point, I can use it just like any other, just like I would within any other experience. So, for example, on my real-time controller, I can add in an existing application. For this purpose, I'm going to choose a shipping example that is just a continuous voltage input for the thermocouple that I have on here. So if I open that example, I can very quickly make sure to deploy this first. Let it deploy. And then from the DAQmx side, all I have to do is go down, I'll select my specific module, I'll go ahead and change the voltage rate again, or the voltage levels to the smallest one, and then I'm going to decrease my samples a little bit here since it's a little slower, and run this. And very quickly now I can see on this product I'm now getting data within LabVIEW pretty quickly, which is very nice. And so I'll go ahead and stop that, and just for the sake of completeness, if I want to, I can open up the block diagram here, and alongside my DAQmx code, if I want to say go ahead and use the I/O from RSI data, I can just drag and drop like I would normally. Now I have that data within LabVIEW real time. And then down below, I can create an FPGA VI, go to the block diagram, take one of my I/O nodes, and drop them into LabVIEW FPGA just like I would on any existing CompactRIO controller project today. So you can see, other than the kind of configuration options up here and having these new buckets in the LabVIEW project, the experience really isn't that different. I can continue to program just like I do today. Switch back to the microphone that I don't have to remember to turn my head right for. Yeah, exactly. And continue on. So that covers the programming modes portion. So switching over to TimeSensitive Networking, or TSN, as you most likely have heard it called many times in the past. This is something NI has been talking about for 2 or 3 years now, and something that we've actually integrated into a CompactRIO controller. We had a couple of sync versions that were available previously that were more of the early access release type. Now this is fully integrated into the product, so every single Ethernet port that you see on any of the new CompactRIO controllers support TSN and its capabilities. For this session, I'm not going to dig real far into what is TSN and what is time-sensitive networking. The main reason for that being is, one, time purposes. Being a little selfish, I want to focus more on the general controller. But also, we have several sessions throughout NIWeek that are focusing on time-sensitive networking. So if you are interested in a more deep dive into technology and understanding it better, there are several sessions throughout NIWeek that we would recommend going to for that. But I will at least give a brief overview. So time-sensitive networking, first and foremost, it is an industry standard. So it is an industry standard for the Ethernet stack down to the bottom couple levels. So this is something that lives alongside things like the Wi-Fi standard that's part of IEEE, as well as things like the 3G and LTE standards that are out there. So this is a standard for Ethernet, and that will help to address a lot of challenges of getting some specific functionality out of the Ethernet network, such as synchronization of distributed devices or communication quickly between devices that are often used within the OT, the operational technology world, but being able to integrate seamlessly alongside the IT side as well, which is a key part of TSN. There are multiple parts of these stacks that have been changed before for very custom things like EtherCAT, for example, and the challenge there being is they don't live alongside your standard network. You kind of have a proprietary network that you have to set up for that capability, and TSN will help address some of those challenges, so you don't necessarily have to create up a specific network just for things like synchronizing or sharing control data across the network. It can live alongside everything else that you have, kind of simplifying that overall network architecture and device architecture, and allow you to better distribute systems. And so whenever we look at TSN, there are really, I would say, two main reasons that we've been interested in integrating TSN into our products. So this industry standard technology into our products. One of them is the synchronization aspect of it. So being able to synchronize distributed systems and distributed measurements across a network, which many people in this room are probably starting to see more, because as things like the Internet of Things become more popular, people are starting to distribute more and more of their systems and split up the task among different products and kind of nodes, if you will. And the other thing is deterministic communications. So being able to do things like closed loop control across the network. So you can have your inputs and processing on one side, and then your outputs, your actuation outputs on the other side, each of which are probably doing some intense processing on one side and intense control on the other, but sharing data quickly across that network to be able to do some fast control loop rates that are distributed. And so looking at TSN specifically on CompactRIO with NI DAQmx and some of the key features here, again, as we look at that synchronization aspect of it, that's going to cover the first several bullets here. So you can synchronize distributed systems. So now if I have a CompactRIO controller over here, I can run a CompactRIO controller over here, and they'll be synchronized if I'm connecting over Ethernet through a TSN supported chain. So I can have synchronized systems, which then I can either synchronize my measurements based on, so I can, with DAQmx, acquire measurement data and make sure that I'm getting the data at the same time across this bigger distributed architecture of this device. Or also just run tasks at the same time if I want to do that as well. And specifically one thing I said I was going to come back to an additional expansion option, which is now that we support DAQmx on these products, we actually have support for compact DAQ chassis. Specifically, the ones I want to call out are compact DAQ with TSN chassis. So from a product perspective, this is CDAC 9185 and 9189, so 4 and 8 slot devices that you see up here. And they do support TSN, so the synchronization aspect of TSN and being able to synchronize data. So there are a lot of applications that are out there where 8 slots of I/O just isn't quite enough. And this is where TSN really comes into play. Before, if you wanted to expand your measurement capabilities beyond 8 slots on a controller, you would likely have to do some type of signal-based synchronization, or maybe route something around for DSA, or do some type of triggering. And honestly, it was kind of a little bit of a challenge to do in the past. It could definitely be done, and if anyone could do it, it's probably this group here, but it certainly was a challenge. And with TSN support, now you can have the same notion of time on your CompactRIO controller and these compact DAQ with TSN chassis. so that you can have your CompactRIO controller, daisy chain up to about 15 or so compact DAC chassis off of that, which is probably more than enough I/O for what you need. And then each will have the same notion of time, so that from the single controller, you can set up a DAQmx task. Anything within that DAQmx task, we're going to automatically behind the scenes synchronize for you. And then you can also synchronize your different tasks so that all the I/O you have in this chain can be synchronized together. And then you get measurements across this bigger network that are synchronized to within 1 microsecond of each other. And 1 microsecond is kind of the broad timing that we use just to be safe, but in reality, you're going to see within the hundreds of kind of low hundreds of nanoseconds for that kind of jitter between measurement signals. So very well synchronized control all over standard Ethernet, so you don't have to develop a specific network or route an additional cable to do some hardware-based methods within the system. And then last but not least, calling out the closed-loop control capability. This is generally more of an advanced feature. You probably haven't seen too many customers who are trying to ask for something like this. And not too many people are quite pushing the edge of the limits today that are going up to the control side. But with TSN comes a standard aspect where we do have the ability to deterministically send network across the traffic. So you can essentially pause other traffic, send a deterministic packet through from one control system to another, and be able to do closed-loop control across a network up to about 4 kilohertz is what we've seen so far for some of these applications to distribute the processing for maybe a very advanced control type application or a very distributed application. But again, it is fairly complex. We've seen a handful of these applications that are there. We've shown some at NIWeek before. That's definitely a little bit more bleeding edge than just the synchronization aspect. And then switching in the last bit to the upgrade features here. And so this is just, again, the nature of it being a replacement product. There's several things you might expect from a product like this. And we did address many of those here, which include several things. So first and foremost, usually you expect to see a performance improvement, which I'm happy to announce is true with these new products as well. So for our CompactRIO 904X, we do have the latest Intel Atom processor, which over previous products is about a 10 to 20% performance bump. And then we're including some of the same FPGAs that we have today. And then for the CompactRIO 905X products that we'll be coming out with later this summer, we're doing about a 2 to 4X processor improvement. So a pretty big bump in processor performance for the low-end variants. And then also bigger FPGA fabric than what we've had previously on the replacement products. So you can do more control or add more features into your FPGA. And I said I would come back to this. On the CompactRIO 904X side, I want to talk about the USB Type-C. Again, several people have been asking this from us in the last couple years or so. We're very excited to bring it in. But I'm also excited to talk about kind of what has helped us offload as well in terms of the overall connections on this. So there's a couple things you probably don't notice on the control that you may have previously. So one being the USB device port, which we had on our previous controllers, which USB device was a great way to be able to help to address that connectivity issue that I'm sure everyone in this room has faced at some point. And this really has helped address that. And we want to make sure to keep that around, but instead of having a dedicated port just for that, we now have in this top board that you see here, something that's called dual role support, which allows it to act as either a USB device or a USB host. So you can either connect to a laptop from it and then kind of develop and deploy and debug your application, or you can use it as a host and connect to it up to some device if you want to. The bottom port, just below that, has host capability, so you can use it to connect to other devices. But it also is actually how we're managing display as well. So you notice there's no display port on board. That's now over USB Type-C as well. And similar to the display port that we had previously, we do have accessories that allow you to go from USB Type-C to VGA or DVI or some other, you can use many other standard connectors like HDMI as well. And so this allows you to take advantage of that embedded UI feature, so you can run a display directly from the controller itself versus having to go through maybe a PC or use something like a TPC if you prefer to just drive it directly from the controller itself. On the CompactRIO 904X, a couple things that I'll call out. One of which I've already talked about the micro SD a little bit in the USB Type-C, so I won't hit that too much more. But one thing I do want to talk about here and call out is we've added an isolated power supply for this low-end variant. It's something that we had on many of our more higher-end CompactRIO controllers in the past to be able to help just generally protect the system a little bit more from maybe improper wiring or some things that may come up that cause potential issues going through the power supply. And so as we were creating this new controller, this is something we actually had to fight quite a bit for, because it turns out to be very hard to integrate it into a small product, because it takes up a good amount of thermal load. But we know, in terms of especially a lot of customers that you work with, we want to make sure that we can kind of help fault-proof this device as much as possible. And this is something that we prioritize high enough that we decided, instead of just having it in the high-end variants, we think it's something we want to have in every single variant that we have. And so we're now integrating this into our lower, kind of more entry-level variants that we offer. So now isolated power will be on every single controller option that we offer. And then I'm just going to pause a little bit. It's kind of an eye chart, and don't worry, it is. This presentation will be uploaded online later if you do want to check out some of the more specific variants. But this is all the variants that we're coming out with. So there's 13 that you can see here that by end of the summer we'll be coming out with, 9 of which have already released and are available. And this isn't including conformal coding options, which we are working on some of those as well. And so the one thing I do want to call out here is a couple specific products. So one is the CompactRIO 9042 and the CompactRIO 9047, which are a 4 and 8 slot controller that specifically integrate a quad-core processor, so our highest end processor in CompactRIO, but also provides an extended temperature range rating. So in the past, we've only offered a dual-core processor and an extended temperature range rating. And we've seen a lot of people that want to deploy into very rugged environments, but also want the most processing capabilities as possible on that processor. And usually they don't need as big of an FPGA to do that intense processing on the CPU. And so what we did was we decreased the FPGA size, increased the processor to a quad core, and integrated that to one product that's now rated for -40 to 70C. So you now have a processing performance point in terms of variance in this product. So this one we're pretty excited about, and we think will be pretty interesting, especially to a lot of those deploying around heavy machinery or remote systems that are deployed outside. So to quickly just kind of recap before we open up to questions, and then there's just a couple more slides here. First and foremost, I just want to recap, again, bring it back to the 3 main things we've been talking about all along. You have the programming mode so that you can really use the right API for the right task. So you can use the right programming mode based on what you're trying to do, so you don't have to use an experience that maybe isn't quite as optimized for it. Second is the TSN support, so to be able to synchronize distributed systems as well as distributed measurements and control as well across the network. Third is the fact that this is a replacement product, so you have a lot of new features, new capabilities that have never really been there before, plus all this new performance, all wrapped into one product. And then it's using the same experience you're used to today, same applications, same experience. So it really shouldn't be tricky at all to migrate to or to leverage for your latest projects. And I want to highlight this as much as possible. The product manager in me wants to just talk about how this is the greatest thing ever, and it's wonderful and fantastic. The engineer in me wants to make sure that, as you're going from here, most people are probably going to be trying to figure out, should I use this on my next project or not? And the engineer in me is morally obligated to tell you some specific things you might want to know before you use this in your next project, which is this next slide here. So one, if you are looking to use this new controller, it does require LabVIEW 2017 SP1 or later, and then CompactRIO or NI DAQmx 17.6 or later, so the specific drivers, which that's generally fairly true with the new controllers, so nothing too surprising there. The next is if you've used the Compact DAQ controllers in the past, we are only offering a NI Linux real-time variant, so if you've used any of the Windows options in the past, right now there's no plans for a Windows option in these new controllers. And then the last 2 bullets are really around C-Series I/O, where C-Series, of course, is very critical to the CompactRIO and Compact DAQ platforms. It's the I/O integration that's very critical, and that quality I/O that you get out of it that's important to these systems. And so as part of that, we do want to support essentially every single module. We want to get all those modules supported to you as fast as possible. And R&D actually worked very well to get just about every single module in there. There's only a very few specific ones that aren't going to be initially supported at release, but we are working on. And that's the one that you see here, which is the HART ASI Profinet Profibus, EtherCAT, and EtherCAT Slave C-Series modules. So those specific ones at release, we don't have support for, but that is something we're working on and we'll eventually get out to you as well. All the standard analog, digital, and other communication types that are up here are all supported in them. And then last but not least is the Powertrain C-Series module. So this is the, we may have heard in the past as the driven modules or the 975X or 9760. These right now we don't have planned support for. I'll maybe just get a gut check real quick from this room. Is anyone using these modules in a project today? All right. Let's get validation. Yeah, there hasn't been as much use for this, so we haven't been moving these forwards directly, but all the ones that you see in that second line there, or third line I should say, are expected to move forward to the new controller for support. So last but not least, then we'll open up questions is, if you're interested in learning a little bit more about CompactRIO with NI DAQmx at NIWeek, there are several sessions that will be happening during the standard NIWeek timeframe. Note one session I don't have up here is the introducing CompactRIO with NI DAQmx. That's because it's going to be the exact presentation that you just saw. And so if you want to go to it again, by all means you're welcome to, but you can probably go to other things such as there's actually a TSN session at the exact same time that you could go to instead. On Thursday afternoon, hopefully you'll still be around, there's a CompactRIO with NI DAQmx kind of technology overview as well as control best practices. So one of our chief engineers will dive into a little bit back, kind of behind the scenes, so the architecture of the product and how we made all these programming modes live alongside each other, and support things like TSN, as well as talk a little bit about DAQmx versus FPGA for control, and we'll give a demo of hardware times single point and showing that for the control. And specifically, I think what this group will be interested in is some of the optimizations that you might do within NI DAQmx for hardware times single point to get the most control capabilities, to get the highest loop rates possible. And then there's several, and then on Thursday, after the other introducing CompactRIO DAQmx session, we're going to have a couple of partners actually talk about their use cases and what they've, kind of how they see this changing the game for them. So you can get kind of some of your peers' perspective on what this product means so far as they've evaluated it for various projects or used it in certain projects as well. And then last but not least is this is going to be shown up several places on the demo, on the show floor. So if you want to go see it in action, there's several applications that are out there that you can go see that are using this today. And so with that, we're getting pretty close to time here. I think I maybe got a little too excited about the product and talked a little too long. But that's okay, we do have a little bit of time here for some additional questions. We'll start. So
is this replacing CDAC also?
So the question is this replacing CDAC also? And this is one place I want to be very clear as well. So CDAC, I'm going to separate it into our CompactDAQ chassis. So that's the USB, Ethernet chassis that you're used to. And then CompactDAQ controllers, which have the real-time processor, or have the processor that can run real-time on Windows. This is replacing the CompactDAQ controllers. This is not replacing the CompactDAQ chassis that be tethered off a PC. Those are still going to exist and are still a separate product from this that live outside of it. So for example, the CompactDAQ with TSN chassis that are showed off, those are brand new, and those we still recommend for the tethered applications to a PC or for expanding off of a controller.
So with that said, is there consideration to have a non-FPGA version available in the roadmap or no?
She said again real quick.
Is there an option to have in the roadmap one without an FPGA on board?
Okay, for the new controllers. Okay, yeah. So the question was, is there consideration to have a controller like this that doesn't support or doesn't have an FPGA? At this point, there's no plans for that, but I think we'd be very interested in understanding what you want to use it as. I think we have a way to, with the new controllers, essentially abstract the FPGA. So you can use this controller essentially like a CompactDAQ controller that doesn't have an FPGA on it. For cost perspective for you, there's no difference. So we bring these in at the same price point we have as the previous ones. So there's no price difference from your perspective that you have there. We've decided to consume that because we want you to have both technologies in one.
For the DAQmx API, how well with the changes does it support dynamic detection and reporting of I/O modules that may change based on customer situations?
So the question was around kind of DAQmx changes that are going on and trying to better understand changes that are going on, whether like some of the like diagnostic site types of stuff?
So, for example, I have a customer that is in a future phase of the project. We only use 4 VA slots, and they want to allow their customers to plug in relatively any I/O module.
Yeah. Okay.
And I've found ways to do it jumping through various hoops in hybrid mode, but it's not very easy, especially detecting what is in there right now in a programmatic method.
Okay.
And so with DAQmx, having the eyes to detect, what hardware do I have attached to my system, what cards, what analog channels, that's something that has always been relatively hard to see with CRIO or CDAP modules in a programmatic fashion. Is it easier now?
Yeah, so if I maybe bring the question back to Rusei, it's essentially more or less, can I set these up programmatically, and has that changed much from the past? So I showed in the demo being able to set up the modules in Max or the LabVIEW project. There is a third option which I didn't discuss, but there is a shipping example for, which is programmatically changing the modes on these. So you can specifically choose whether they're by slot, whether they're DAQmx, FPGA, real-time scan, whatever mode is specific for that. So programmatically you can set this up to be an appropriate one. And we do provide a lot of the same features today in terms of identification, especially within DAQmx, to understand what the module is and collect some of that data. So in terms of whether it's easier or not, I don't necessarily know that we've made it any easier. And I'll maybe open up to some of our software guys in the back to see if they have any thoughts, but a lot of that capability is certainly possible. Yeah, Curtis wants to.
Yeah, so you'll see everything in system configuration now. Even regardless of the mode, it'll come up and identify as that particular module, and then you'll be able to programmatically change the mode, as Eric mentioned. But I think you should have a better identification experience for this.
I think you might have touched on this, but is there any performance trade-off with using the different modes and modules? You get a faster, you get a faster loop rate, sure, but is there any performance as far as like resources?
Yeah, so in terms of performance and resources that are taking, which is kind of the question, there really is, if they are 2 separate paths. So let's say, for example, you already have an FPGA application, you want to add some waveform measurements to it. You can do that in DAQmx. It'll be a completely separate route, so it will consume 0 FPGA space. And it's a separate hardware-based route that gets you data back very quickly. Like you would expect, and is now also deterministic if you wanted to do some control there. So from a FPGA side, using DAQmx doesn't consume resources, and vice versa. If I add an FPGA when I'm using DAQmx today, those are 2 completely separate things. And there's both can be used. So one thing I didn't call out, but the path from FPGA to the processor has increased. Previously, for these products, we were about 250 megabytes per second. For the new controllers that we have, we've actually updated it to now you can see closer to about 400 megabytes per second throughput between the FPGA and the processor. On the DAQmx side, there are technically configurations that you could get into that is too much data to string through DAQmx, but you get pretty close to like 8 slots full of our fastest modules going at the absolute rate possible, which doesn't really lend itself to a realistic application. Not many people are really doing that. So we have confidence that either path can meet the needs for any of the realistic applications that are happening today. Yeah.
I didn't see it on your migration chart, but do you know how long you're going to still sell the CRIO 9067?
Sure. Yeah, so I'll even expand that a little bit of kind of what happens to our existing products that's replacing today. So 0906X, 0903X are compact DAC controllers. And so while we bring in these new products, we're going to treat this just like we would any other CompactRIO controller or compact DAC controller. So as we introduce this new one, we're not going to certainly immediately end of life our existing products today. For CompactRIO controllers, we try to maintain at least 10 years availability in the market. So if we look at different ones, so 906X, the latest one released was in 2015. So our goal there is to have them available until at least 2025. And the same is actually true for our 903X controllers. We are expecting to try and maintain that life cycle goal. Of course, that is our target. Sometimes things happen where we may not be able to, but certainly we have service options available as well if there's an application that needs to for sure guarantee a certain amount of time. And the same is true for our compact DAC controllers. We're going to keep them around. Because in many cases for a compact DAC controller audience, if your customer designates no matter what, they have to use Windows as the operating system, that's the only option available in this form factor today is on the existing compact DAC controllers.
One other question on the identifying the modules. We actually do a lot of that. Do you know if our existing code still works?
How about I talk to you offline? And we
Okay.
can catch up on
Are there any changes for the third-party suppliers and the interface between the C-series modules and the FPGA part?
Yeah, so it's a good question. And the question is around third-party modules. Is there any change there? So the third-party modules are based on a module development kit. Pretty much all of the ones that you would use today are based off of the latest NDK 2.0. We did have to update to an NDK 2.1, which isn't really much of a program change. It's not like they will have to do a big overhaul, but there is some testing required there. So I will say we recognize this aspect pretty late. So most of the partners we let know around the release of the product. So if you're working with a third-party module and want to use the new controller, we'd recommend reaching out to that partner and verifying that they've updated the latest NDK 2.1. Most of them have or are working on it at this point, but it's one thing you can just verify with that partner. And they should know this. If there's any partners in the room that build custom modules and don't know this, okay. We can.
Motivate them
Okay.
what the changes are.
Awesome.
Which
Which company?
CTS.
Okay. Yeah, we can certainly talk offline as well. So I'll go ahead and stop here because we're getting close to the time for the next session. If there are additional questions,